All right, today we're talking about building a better factory brain. We're going to dive into the hidden design principles behind the screens that run, well, pretty much everything, from power plants to massive production lines. So, what makes these interfaces so important? And how in the world are they built to be lightning fast? Let's get into it.
You know that feeling, right? When your tablet is just lagging or some app is super confusing to use. It's frustrating. But now, imagine that same clunky, slow interface isn't for watching videos, but for controlling a gigantic, multi-million-dollar factory. All of a sudden, that little bit of lag, it's not just annoying anymore. It's a massive, potentially catastrophic problem.
Yeah, in the industrial world, every single millisecond, every click, it all counts. A badly designed control screen, it can grind production to a halt, waste mountains of materials, and in the worst case scenarios, it can be downright dangerous. I mean, the stakes really couldn't be any higher. So the big question is, how do the pros actually do it? How do they build interfaces that are totally rock solid, super responsive, and crystal clear, even when things get intense? Well, we went straight to the source. We dug into a super detailed engineering guideline from Siemens that pretty much lays out the entire blueprint for these high-performance industrial screens.
Okay, so the very first principle is all about being ruthlessly efficient. It's called Build Lean, and it's basically a philosophy of disciplined minimalism. But this isn't just about making things look empty or sparse. It's about making every single thing you put on that screen earn its place. It has to fight for its right to be there. And the guideline really puts it perfectly. The whole goal is to use the absolute fewest objects you can get away with. And for every single one you do use, you have to pick the version with the smallest possible footprint. So, what in the world is a footprint in this context? Well, a footprint is basically the rendering effort. You know, how much processing power it takes for the system to just draw that object on the screen. And as you can see, not all objects are created equal. Not even close. A simple rectangle, super cheap to render. A text box with all its different properties, that costs a bit more. And a full-on button with different looks for when it's pressed or released, that's the most expensive of the bunch. So this all comes down to picking the right tool for the job. Let's say you just need a colored box on the screen. That's it. You could use a text box object and just leave the text blank, but that's the heavy way. The lean way is to just use a simple, lightweight rectangle. You get the exact same look, but it's way more efficient because the system has so much less to think about. Here's another classic example. You see this all the time. Imagine you need a button to show or hide something. The cluttered, inefficient way to do this is to make two separate buttons, one that says show and another that says hide, and then you stack them on top of each other and just make one visible at a time. You're using two objects to do the job of one. But the smart way, the lean way, is to use just one button. A simple little script can check if the thing is visible or not, and then just change the button's text and what it does right on the fly. You get the exact same result for the user, but you're only using half the objects on the screen. That is what building lean is all about. Okay, so you've built this lean interface. You've only got the parts you absolutely need. Now, how do you make those parts come alive? That brings us to the second principle, dynamize smartly. And this is all about how the screen reacts to real-time data from the factory, like a tank level that's going up and down or a motor's current speed. And what's so great about this is that the guideline gives you a really clear hierarchy of choices. Think of it like this. The simplest, fastest method is what they call tag dynamization. That's like a direct hardwire connection between the data and the object. If you need a little bit of math, maybe to convert some units, then you step up to a formula. And I mean only when the logic gets super complex, do you pull out the heavyweight tool, a full-on script. So the main takeaway here is to always start with the simplest, most efficient option. It's like climbing a ladder, right? You always start on the bottom rung. That's your direct tag link. You only climb up to the next rung, to formulas, and then finally to scripts when you absolutely have to. It's that kind of discipline that keeps the whole interface feeling snappy and responsive. All right, so you've built lean, you've dynamized smartly, what's next? Well, now it's time to work smarter, not harder. This brings us to our third principle, reuse and standardize. The idea here is actually really simple. Once you build a perfect component, you should never ever have to build it from scratch again. And the key concept here is something called a faceplate. The absolute best way to think about this is like a prefabricated part for your interface.
So imagine you've designed the perfect set of controls for a motor. You've got the start button, the stop button, the speed display, the whole shebang. You group all of that together into one single faceplate. Now, for every other motor you add to your system, you just grab that one pre-built, perfect component and drop it in. Done. But wait, when should you use a faceplate versus just a simple custom style? Well, the guideline makes a really clear distinction. Think of it like this. Use a faceplate for function, for those complex, multi-part controls that you're going to use over and over again. And use a custom style for form. That's for defining a standard look, like your company colors and fonts, for a single type of object across the whole project. And this whole philosophy of efficiency goes all the way down to something as simple as a pop-up window. The guideline basically gives us this simple decision process. If a pop-up is really complex, yeah, you build it ahead of time and just have it ready to go. But if it's simple, you can actually create it at runtime, which means the system literally builds it from scratch the exact moment the user clicks the button. The benefit? It keeps your initial screen load times incredibly fast. Now, here's the cool part. These principles, they're not just abstract ideas or suggestions. They are backed up by a whole suite of powerful analysis tools. This means engineers don't have to just guess if their design is lean. They can actually measure it and prove it. So, what are these tools of the trade? Well, the guideline points out a few key ones. There's an add-in that can give you a bill of materials for your screen. It literally counts every single object so you can see how complex it is. Then there's the trace viewer, which is kind of like a diagnostic tool for a car. It lets you see all the system's internal messages in real time to find any bottlenecks. And, of course, the script debugger, which lets you go line by line through your code with a magnifying glass to find and squash those tricky bugs. And all of this really brings us to one final big idea. Building a better factory brain, it isn't just about following a bunch of technical rules. It's really a whole design philosophy. Because as the machines and systems we control get more and more powerful, the real challenge, the human challenge, is to keep our interface, our window into all that complexity, as simple, clear, and efficient as we possibly can. And you know what? That's a principle that goes way, way, way beyond the factory floor.